Hi everyone, what's up? Welcome back to my tutorial channel. Today we are going to finish the last lesson in IFM series lectures, and after that we are going to focus on problems and tricks for the exam. So the lesson today is about delta hedging and gamma hedging. So it's very simple. We are going to go by one, delta, then gamma, and some exercises. So first, let's look at the targets of the lesson. The targets of this lesson is first, know how to perform delta hedging by calculating the quantities of option units and stock shares to hold, and whether those positions should be long or short. Long or short here basically just like either sell or buy. Is it sell or buy? Number two, we need to know how to perform gamma hedging by calculating the quantities of option units of various types and stock shares to hold, and whether these positions should be long or short. Again, long or short here means whether we buy or we sell in order to have either a long position or a short position in a portfolio. Let's say, for example, if I sell, then it should be short, but if I buy, it should be long. So first, before we talk about delta hedging, let's go to a very basic thing, that is replicating a portfolio. Consider a portfolio with the value VST. That means the value here depends on the stock price and the time frame. And let's say we want to replicate this portfolio by N shares and B dollars. So the question is how to evaluate N and B. That is the main point of replicating a portfolio, and also the main point in delta hedging. Remember here, if we assume that N is the number of shares and B is the dollars amount, then the value of the portfolio is N times shares plus B. And now in order to calculate N and B, we will have to use some measure that we learned from the Greek option. In the last lesson about Greek option, we learned about a couple of different measures like delta, gamma, vega, psi, and rho, right? So for this one first, if we want to solve for N, we see that N here is the coefficient of S, and B is a free constant, which is not dependent on S. So in order to withdraw N from here, we basically can just differentiate both sides with respect to S. So B will be cancelled, and the right side become N, and the left side is delta. So that's how we determine N. So now let's differentiate both sides with respect to S. We got delta. Remember, delta V over delta S is delta from the last lesson. And when we differentiate in S plus B, we got N. So here, obviously, N is just delta. And use N, we can solve for B, right? Because S is given, V is given. So we can find B from this equation. So if we withdraw B from the two equations above, we got B is V minus NS, and V is equal to B is equal to V minus delta S, right? All right, and delta here is the delta of the portfolio. Okay. All right. Now let's take a look at a very special case of portfolio. Let's say we consider European cars or put. Let's look at the car option first. Remember, in the European cars, the car's price is CSKT minus T. This is the price at time T, at time liter T. That means the time to expiration date is capital T subtract liter T. So the car price here is S of T times E to the minus delta times T minus T phi D1 minus K E to the minus R T minus T phi D2 from the very last lesson. And from here, if we differentiate both sides with respect to S of T, then N is the number of shares should be equal to delta of car. Delta of car. and it should be equal to e to the minus delta times t minus t times phi d1. And from here we withdraw b. b here is just v minus ns, or the call price subtract s of t times delta call. And it should be minus k times e to the minus r times t minus t phi d2. And here I use color to make it easier to recognize. You see, everything in the green colors are the same things. Everything in the red colors are in the same things in this call values. And similar for a put value, if we consider European put option, then we got the put value is k e to the minus r t minus t phi of minus d2 minus s of t e to the minus delta t minus t phi minus d1. And then if we differentiate with respect to s, we got the delta put here, right? And n here is, it looks similar to the delta of call, but you switch side. We flip the side for e and the side for d1. And similar from once delta is given, when n is given, we can find b by subtraction. So that's how we find n and b for the replicating in European calls and put. Now if we consider delta hedging, delta hedging is a very special case of replicating a portfolio. So basically delta hedging here mean like we just have to purchase minus delta shares of the stock and hold cash position for W is equal to minus B, which is equal to minus V plus S times delta. Basically it's just like in order to hedge the risk of the position of the holder, they can just sell the replication portfolio. So here delta hedging means we sell. We purchase and we sell. This is the main point in delta hedging. Alright, if we differentiate with respect to S, then we got like delta of the derivative minus delta times delta of stock should be is equal to 0. So for delta hedging, the main thing we need to do is make sure that the delta of both sides should be cancelled out. The advantages of delta hedging. Delta hedging will help reduce fluctuation in the value of the portfolio. The fluctuation of the value in the hedges portfolio is typically small. During a small change in time, gamma, theta, and also the interest gain or loss on the cash component is also small. So the sum of these three should be also small. The explanation for it can be found in some textbook and some resources, but I don't mention them here because they are not really important for IFM. For IFM exam, you should need to know that the advantages of delta hedging is to reduce the fluctuation of the value of the portfolio. You don't really need to know why. Alright, so that was delta hedging. Now we talk about gamma hedging. Gamma hedging, delta hedging try to balance delta, make delta 0. However, for some big changes, delta hedging would not be effective. And that's the reason why we have to use gamma hedging. So the answer to why gamma hedging. Remember that delta hedging can only protect the market maker against small changes in stock prices. If the gamma of the portfolio is negative, a big change in the stock price will lead to a big hedge loss. And that's why gamma hedging is a solution to solve this problem. So how does it work? It's really simple. All we need to do is just zero the gamma, and we just need to solve the following equation for V. So here we got gamma is second derivative of V respect to S, and we need to zero out the gamma. And to adjust the gamma of the portfolio, we should choose the option that are not linearly dependent to the underlying asset. So the optimized option are the ones who both gamma and delta 0. So that is how gamma hedging works. Alright, so that was all for the lesson. Now let's consider a couple examples to understand better about delta hedging and gamma hedging. Example 1. for a non-dividend paying stock that follows the Black-Scholes framework, you're given the initial stock price is 58. The stock volatility is 0.35 or 35%, and the risk-free interest rate of the environment is 0.1, which is 10%. Let's say Mary had just sold 100 units of a 6-month cyclic call option. To hedge the risk, Mary immediately hedges her position by purchasing the hedge portfolio. Calculate the components in Mary hedge portfolio at time 0. That's a question. Alright, so basically calculate the components in Mary hedge portfolio at time 0 here means we have to determine the number of shares and the value of cash borrowing in this hedges portfolio. So we aim to determine N share and B dollars in the hedged portfolio of 100 units. First, record the Black-Scholes call option model at time 0. Here at time 0 means literal T is 0, right? So call option as S0KT is equal to S0 e to the minus delta T phi D1 minus K e to the minus RT phi D2. Remember, delta here is 0 because it's not given in this lecture, in this problem. Alright, now in order to find N, we basically have to find delta of call. Means we have to differentiate both with respect to S0. So N here is delta of call, which is e to the minus delta T times phi of D1. And delta here, the literal delta is not given. The dividend U rate is not given. So it's just 0. That means no dividend. Because this is non-dividend paying stock. So that means literal delta is here is 0. And B here is minus K e to the minus RT phi D2. So in order to determine N and B, we first need to determine D1 and D2. D1 here is, just follow the formula. We got D1 is 0.1888 and D2 is minus 0.0587. And from here we have N is just 0.5749. Just plug into the equation. B is minus 27.20. That's for 1 unit. This is 1 unit for the call option. Now, because Mary had just sold 100 units, so everything here N and B, we have to times 100. So we got the hedges portfolio of 100 units consists of long-in 57.49 shares and borrowing $27.20. See that? Alright, just have to times 100. You see, times 100. And remember that for minus it means that we sell, and for sale is long in. So excuse me, for minus it means sale, and for plus is mean buying. So here, because we have 0.5749, which is a positive number, that means we buying. And because we are buying, so it should be longing. Buying is the same with longing. And selling is the same as borrowing or selling. Alright, example 2. For a 2 European call option, call 1 and call 2 on a stock, you are given call 1 with these information, delta, gamma, and vega. Call 2 also have delta, gamma, and vega. Suppose you just sold 1,000 units of call 1. Determine the number of units in call 2 and the stock you should buy or sell in order to both delta hedge and gamma hedge your position in call 1. So here, remember that when you sell, it's negative, and when you buy, it's positive. So here, let's say X is the number of units of calls 2, and Y is the number of units of stock you should buy. So they should be on positive side. And the 1,000 units that we sold of call 1 should be on the negative side. So now we have two sides of the equation, right? So we have 1,000 times delta 1 is equal to X times delta 2 plus Y. And 1,000 times gamma 1 is equal to X times gamma 2 plus Y. And from here, we just plug in the number. We have two equations. And this is a system of linear equation of two variable x and y. So go ahead and solve for x and y. This is basic algebra, college algebra. We got x is A72.65 and y is minus 95.81. And again here, y is the number of units of stock you should buy, but because it's minus, so that means you have to sell. So we sell 95.81 units of stocks, and we buy 872.65 units of call 1 option. Again, minus means sell, plus mean buy. Plus mean buy. And sell here means shorten, and buy here means longen. So another way to answer is just like we shorten 95.81 units of stock and longen 872.65 units of call 1. So that's how we explain this situation. Alright, so that is it for everything. Thanks so much for watching. And after this lesson, I'm gonna stop making lesson. I'm going to post and trick exam, some important formulas, and some exercises. Like probably every week, I'm gonna post like 10 problems, just 10. Like I'm gonna go and go by topic to topic, like 10 for each topic, until I finish everything. Alright, thanks so much. See you next time.